Okay, now we want to move towards how can we solve this problem. In order to understand the process of solving this, we make the observation that this graph can be mechanically converted to a linear programming problem. What we're trying to do here is trying to minimize the overall cost of operating, the overall cost of the flow through this network. So the flow is from the factories towards the warehouse, and we pay transportation cost. So we are going to find an equivalent, and we will not need to do this every time. Just to understand what to do next, we need to go through this step. But once we understand what to do next, we will not need to do this again. So the equivalent, in the equivalent linear program, we're going to let xij be the flow in arc ij. That means from node I to node j. So for example, xf1 w1 is flow from factory 1 to warehouse 1. And so the same thing for all the variables. And there will be as many variables as there are arcs, and we exclude the injections and the withdrawals. So if we do that, we have 1, 2, 3, 4, 5, 6, 7 arcs for all 7 arcs. And each arc has a per unit cost. So really the objective function of the LP is to minimize 900 x f1 w1 plus 400 f1 x f1 to dc, and so on and so forth. So put dot 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 and just keep on multiplying the cost of each arc times the variable associated with that arc. Finally, you might get to 200 x w2 w1. And that represents the objective function. Now when it comes to constraints, we have subject to. Every arc is going to be bound by some kind of upper bound, ij, and has to exceed some lower bound, ij. So for example, x dc w2 has to be less than 80 and between 80 and 0. And we're going to have as many of these again. For all 7 arcs, we're going to have some upper and lower bounds. Most of the upper bounds are infinity, and we can use a large number like 9999 to express that. We have another constraint, and that is that for each node, this is for each arc, for each node, there'll be a total of 5 nodes. We observe that the flow out of that node has to be equal to the flow into that node. That the flow out minus the flow in has to be 0. And so for example, x f1 w1 plus x f1 dc plus x f1 f2 has to be equal to 50. And we're going to have a total of 5 such constraints. And with this and what we know about solver, we may be able to move to the next step.